So can you see my screen?
Yeah.
Awesome. Um, Hi, I'm Chen Zhongwu, and I'm working on the AsyncContext proposal with Justin Ridgewell. And this time, I'm going to introduce AsyncContext with the usage on the web performance and the OpenTemperature use case on the web. This is a very quick introduction so that we can discuss the usage more in detail. And the AsyncContext is a ECMAScript built-in API. It can implicitly propagate values through code stacks, preserving their values across async boundaries. This AsyncContext class has three methods. The first is the static method wrap. It captures the current global context in the returned callback, which means you can call the callback in a later time to store all the async context values as if it is a current context. And it has a run and get method, which represents get and set operation on the async context instance. The run method runs the callback passed in with the value set in the context when the callback is being invoked, and the value will be propagated implicitly across the async boundaries. And the get method just returns the value in the current context of the async context instance. Let's see an example. In this example, we instantiated a new async context instance, and we call the same function fn with different expected values and different context values. You can see that in the function we awaited some promise, and the value in the context will be persistent across the async boundaries, regardless of the function is being called in a synchronous way, which means the two invocation will interleave with each other, but the value in the context are persistent across async continuations. And this async context can be helpful when we on the web when we are tracing soft navigations. Like say when a user interacts with the page and the interaction initiated a subsequent async operations, it is critical for us to when the HTML is being updated, it is critical for us to know which operation initiated which user interaction initiated these chains of interaction. So that can be also useful for sensitive task attributes, like say runtimes can schedule tasks with priorities. However, the task priorities attributions is not sensitive at the moment, so we have to perform yield or wait to propagate the priorities. With the mechanism of async context in the language, we can propagate the task priorities with native async await syntax. That is to say, we can simply perform fetch and await the response, and the priority can still be observed. This can be useful, like say, in the execution priorities and the fetch priority, or even be used in the privacy protection metadata propagation. And in the application monitoring libraries like OpenTelemetry, we are tracing. The OpenTelemetry saves their tracing spans in the async context, and they can choose the spans when they need to determine what started these chains of interaction. And those libraries cannot intrude the developer APIs for seamless monitoring, so they cannot introduce any additional parameters to existing libraries. So for seamless monitoring, they can use the AsyncContext as to propagate their spans and to they can use the AsyncContext to propagate their tracing spans. Currently, Zone.js is the only option for context propagation. However, Zone.js doesn't work well with ECMAScript async await syntax since it's a so for applications using Zone.js, they need to downgrade transpilation to pre-ES 2017, and however, this is not optimal for for many applications. So with AsyncContext, applications can obtain the native support with the async await syntax with on the context propagation, and this is very fundamental to OpenTelemetry since OpenTelemetry instrument user interactions with document elements and then connects the subsequent network request and the history state changes. They typically there may involve several promise continuation, like say we fetch the first address, and in the response we can continue to fetch another network address. And OpenTelemetry instruments the fetch APIs and create spans for each fetch invocation, and the invocation the span must be nested, and so they will need to determine the initiator of the fetch call. With the AsyncContext help, this can be very this can be seamless without user code changes, and it can generate spans like shown in the example. The click event initiate nested network requests with their detailed network timings. Also, OpenTelemetry supports can instrument long task, collect long task timing entries with the help of long tasks API. However, tracking long tasks effectively, we'll need the ability to trace to tell where a task was spawned from. However, currently it is not able to associate long task time entries with the initiating trace spans. Like say in the example, we don't have any optometry is roughly creating a new performance observer. In the performance observer, there is no way to tell whether or not my task function is called in a tracing span. If the long task APIs is integrated with the AsyncContext, userland application monitoring can tell the long task initiator in the performance observer callbacks and associate the long tasks time entries with the initiating tracing spans. Similarly, resource timing entries observation has the similar problems. We cannot tell exactly the initiator of an resource timing entries, and currently optometry instruments the batch API with the resource timing API with not an intuitive approach to associate the resource timing entries with the fetch spans. Like in the example, we are currently searching finding spans for each resource entries with guessing their names and their starting times to see if a span is the initiator of an performance resource timing entries. If it is resource timing entries can capture the async context, or with the ability to tagging the entries, it can be much intuitive for application monitoring tools to associate resource timing entry with their initiate spans. And this is all my content. Is there
Yeah, let me stop the recording and we can move on to questions.